Very simple method, right? So next method also we are going to see, and the next method is also a sequential search method. But here what is happening, it is designed in such a manner that there will be less computations, right? And the larger area, the larger area is getting eliminated, or the area which is not required, the maximum area from that will be getting eliminated, right? Plus the computational work will also be less. And that was the thought when this method was particularly drawn, right? I'll be just explaining, and one simple numerical will be taking. It's a very simple method actually. And let's understand. So many of you have heard this word Fibonacci, right? So Fibonacci series or Fibonacci method, you would have heard this method, right? So many of you uh, in mathematics would have heard of Fibonacci numbers, Fibonacci series. So now what this Fibonacci method does is that it uses the Fibonacci numbers to place the points, right? So the placing of x1, x2, x3, x4, x5, x6, all this is done with the help of the Fibonacci numbers. And the Fibonacci series goes like this. The in Fibonacci number series, in Fibonacci number series, your f0 is equal to 0, f1 is equal to 1, and then there is a generalized formula, fn is equal to fn minus 1 plus fn minus 2, where your n is equal to 2 comma 3 comma 4 comma and so on, right? Very easy to understand. When I'll be writing these numbers, it is very simple that to understand. So the Fibonacci numbers in series are given as, right? So first we will be having f0, which is our one. F0 is equal to 0, f1 is equal to 1, f2, f2 is what, particularly it is 1 no, f2 is 1 plus 0 is equal to 1. f3 is previous addition of previous two numbers, 1 plus 1 is equal to 2. f4 is equal to 2 plus 1 is equal to 3. f5 is equal to 5. f6 is equal to 8. Similarly, right? f7, 8 plus 5 is 13. f8, 13 plus 8 is 21. f9, 21 plus 13 is 34. f10 is 34 plus 21 is 55. Similarly, f11 is 89. f12 is 144. So you can write f13 as 233, f14 as 377, f15 as 610, f16 as 987, f17 as 1597, f18 as 2584, f19 as 4181, f20 as 6765, right? So these are all, I've written it till f20, you can go on, right? So this is called as the Fibonacci series. So Fibonacci series is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1597, 2584, 14181, 6765, and so on. So it is very easy to remember, easy to derive, right? So it is just the addition of previous two numbers, right? Now how this is going to be used in the placement of the experiments, that we are going to see, right? So the placement of the experiments is done in following manner, right? So I'll be explaining it with the help of the numerical only. So no, it will be helpful for us also. Numerical भी हो जाएगा और आपका explanation भी उसी के इसमें आ जाएगा, right? Now the question that we have is, the criteria of the question will be same, only the name of the, the type of the question will be same, only the name of the method that they will be telling us to use will be different. So use the Fibonacci method to maximize f is equal to 16x minus 0.2 x square in the interval of 0 to 100 to an accuracy of 0.1%, right? So this is the numerical, right? They have clearly stated use Fibonacci method. The objective function is to maximize f is equal to 16x minus 0.2 x square. The interval that is given is 0 to 100 and the accuracy that is expected is 0.1%. Now here, very importantly, the accuracy here is very, very important, right? And it will be helping us to select the the maximum Fibonacci number, right? So the relationship goes like this. Uh, your Fibonacci number 1 by the reciprocal of the Fibonacci number is less than or equal to your alpha, but here alpha given is 0.1%, right? So we'll have to write it properly. 1 of n is equal to 10 upon, right? Oh, sorry, 0.1 upon 100, right? Therefore I can write 1 upon fn less than or equal to 0.001. Now taking the reciprocal of 0.001, what I can write is fn should be greater than or equal to 1000. So if I take the reciprocal of 0.001, that is 1 divided by 0.001, it happens to come as 1000, and changing the direction of this inequality sign, so here fn comes out to be 1000. So what they are telling us is that the above statement, I will be writing here so that you don't forget, the above statement suggests that the Fibonacci number should be just above 1000, right? So if we remember the Fibonacci series, it was 0, 1, 1, that is 3, 5, 8, 13, 21, 34, 89, 144, 2, 33, 377, 610, 987, 1597, right? So the Fibonacci number, which is just about 1000, coming out to be 1597. 987 we can't consider because 987 is less than 1000, and no, we are not going to get exactly 1001 as a number in the Fibonacci series. So the number that is just above the 1000 is which? This is 1597. Hence your Fn, that is the Fibonacci number, is given as 1597, right? Then your Fn minus 1 will be what? It will be 987. Fn minus 2 will be what? It will be 610. Fn minus 3 will be what? It will be 377, and so on, right? Till Fn minus 16 is equal to what? It is equal to 1, right? So this is very, very important because this will be needing in our formula itself, right? So when we identify Fn, we automatically get what is the value of Fn minus 1, Fn minus 2, Fn minus 3, just will have to come in the reverse manner, right? So I'm hoping that till now there shouldn't be any doubt, right? So now what we are going to do is that we are going to use this Fibonacci numbers to place our experiments or place our points, right? So here let's say stage 1, In stage 1, our initial interval is what? Initial interval. I will be saying it as I0. So I0 is equal to 100. Yeah, it was 0, comma 100. So 100 minus 0 is equal to 100. So this is our initial interval, right? Now, the beauty of this Fibonacci method, no, or characteristic of the Fibonacci method is that we are now, considering 2 points, x1 and x2, considering x1 and x2, such that these are equidistant from the ends. For example, no, now here I can consider it as 0, here it is 100, right? So this is my I0 complete interval. So now I'm going to place my x1 and x2 such that they are equidistant from their corners, or the equidistant from their ends, right? So I'll be naming this distance as I0 star, and this is I0 star. Okay. So this is x1, this is x2, and this has been placed in such a manner that your x1 is x1. The distance I0 star is maintained at both the ends. Now, how to find this I0 star? There is very simple formula. I0 star is equal to I0 into Fn in the denominator, and here it is Fn minus 2. All these values we already have. I0 का value कितना? It is 100. Fn minus 2 का value कितना according to the series? If you look at the series, the Fn minus 2 comes out to be a 610, and Fn we already know it is 1597, right? So if we do the calculation, it comes out to be 38.2. Right? Now, how to decide x1? x1 is equal to what? x1 is equal to 0 plus I0 star, बराबर? और I0 star का value कितना है? 38.2. So it is 38.2. What is the value of x2? x2 is equal to 100 minus 38.2, right? And the value is 61.8. I'm hoping that you have understood how we have found out the value of x1 and x2. We initially knew I0, putting the value of I0, and then then applying the formula for finding out the distances I0 star. We get the I0 star as 38.2, and no, just finding out the x1 and x2 from the values from either ends, we will be getting the value of x1 as 38.2 and x2 as 61.8, right? Now we can substitute this in our equation, right? F of x1. So what is our equation? It is 16x. So that is 16 into 38.2, minus uh, 0.2 into 38.2 square. So if you do this calculation, the answer comes out to be 319.35. Similarly, f of x2, it is 16 into 61.8 minus 0.2 into 61.8 square. If you do this calculation, it comes out to be 224.95, right? So now, x1, f of x1 is 319.35, 319.35, and here it is how much? 224.95. The example, if you remember, it is of maximization type. So no, what we'll have to do here, we can write f of x1 is greater than f of x2. Therefore, eliminate. Which region can be eliminated? Eliminate the region. Which region? Eliminate the region left of, sorry, right of x2, right? So we are going to eliminate the region right of x2, and the new interval that we get, will be what? The new interval will be 0 comma, and what is x2 value? It is 61.8. So this is our new interval, right? So we are going to proceed in the same manner for our next interval, right? So right? So stage 2, new interval is new interval is 0 comma 61.8, right? So the value of I1, right? Previously we have found out I0. So here I1 will be what? 61.8 minus 0, that is 61.8 only, right? So now here, so you can say, considering points x3 and x1 and x2, yeah, x1, x3 and x4 equidistant from the ends, we can find out I1 star. Now, how the formula will get modified? I1 star is equal to, no, I1 into Fn minus 1 upon Fn minus 3. See, previously the formula what? I0 star is equal to I0 into Fn and Fn minus 2, right? So you have to remember, right? There is a style, no, you can remember. My method of remembering this formula is, right? So previously, initially it is Fn, and then we have to move 2 digits back, so Fn minus 2, right? Nextly, when we move ahead, no, the denominator will be Fn minus 1, right? And again, then we'll be moving 2 digits back, Fn minus 3. Similarly, for I2 dash, what it will be? I2 dash will be equal to I2 into, now it was Fn minus 1, so we are going to write Fn minus 2, and in numerator we are going to move 2 digits back, that is Fn minus 4, right? For I3 dash, it will be I3 into, in the denominator, previous it was Fn minus 2, it will be Fn minus 3, and moving 2 digits back, that is Fn minus 5. I'm hoping that you will be able to remember this formula, because it is very, very easy. So which formula we are going to consider? We are going to consider the formula for I1 star. So I1 star is equal to, the value of I0 is 61.8 into the value of Fn minus 1. So Fn minus 1 is 987, right? कितना होता है? Fn minus 1 is, yeah, it is 987, and here it is 377. So the value of I1 star that we get is 23.60. So now what will be the value of x3 and x4? X3 will be, yeah, we didn't draw the diagram, so here it will be 0, it is 61.8, right? And here it is x3 and x4. So x3 and x4, right? So x3 will be 0 plus 23.60, so it is 23.6, and x4 will be 61.8 minus, yeah, 23.6, so the value comes out to be 38.2, 38.2, right? So now here we can find out f of x3 and f of x4, right? F of x3 comes out to be, I will be directly writing the value 266.208, and here it comes out to be 319.35, right? So f of x4 is 319.35, and here it is 266.208. So we should remember what is our objective. It is to maximize. So the objective is to be maximization. So here we'll be able to write f of x4 is greater than f of x3, right? So which region is to be eliminated? Therefore, eliminate the region left of x3, right? Therefore, new interval that we are going to get, will be what? What is the x3 what is the x3 point? X3 point is your 23.6, and lastly it is 61.8. So this is how your stage 2 gets complete, right? So let's move ahead till we get an optimum value in this. So this is your stage 2. So let's complete stage 3 as well. So stage 3. So your new interval that we have got, yeah, the new interval is your 23.6 comma 61.8, right? So here we can find out I2 value, that is 61.8 minus 23.6, which comes out to be 38.2. Now no, let x5 and x6 be the points equidistant from the ends, right? So we can find out I2 star. Now I guess you can remember the formula. I2 into, previously it was Fn minus 1, where if it will be Fn minus 2, and in the numerical it will be Fn minus 4. Substituting the values, I2 we have, it is 38.2 into, the values are 233 divided by 610, and it comes out to be 14.6. All right. Now, we can find out the values here, 23.6, and it is 61.8, right? So we have x5 and x6. So the value of x5 will be, okay, the value of x5 will be what? 23.6 plus 14.6, and x6 will be 61.8 minus 14.6, right? So the value of x5, if you calculate, the value of x5 comes out to be 38.2, and the value of fx6 comes out to be 47.2. So if you find out what is the values of fx5 and fx6, the value of fx5 comes out to be 319.35, and for fx6 it comes out to be 309.63. Yeah, again, if you compare the value of which fx5 is greater than fx6, so what we can do is therefore eliminate the region. Which region is to be eliminated? fx5 is greater and fx6 is on the smaller side, 309.35, and it is 309.63. So which region is to be eliminated? The region right to x6. Therefore we will be getting new interval, and the new interval will be what? No, right of x6 is totally eliminated, so the new interval will be 23.6, and x6 is your 47.2. Till now we haven't got the two functional values are same, so we'll have to move ahead. So let's move and try out, in next one or two iterations we can particularly get these values same. So stage 3 we have completed. Let's move for stage 4. Right? In stage 4, the new interval that we had, as previously decided, new interval is our 23.6 and 47.2. Yeah, it is 23.6 and 47.2. Right? Now, let okay, I can find out I3 value. I3 value is 47.2 minus 23.6, and that comes out to be 23.6. You can write let x7 and x8 be the points equidistant from the ends, right? So what we can now find out, I3 dash. I'm hoping that you remember the formula I3. Yeah, previously it was n minus 2. So here if it will be n minus 3, and 2 digits back, that is fn minus 5. So I3 is 23.6 into fn minus 5 is 144, and it is 377. So the value that we get is 9.8. 0 2, right? So no, we can draw this line here. So interval of 23.6 and 47.2, so it is x7 and x8 here, x7 and x8. So the value of x7 can be what? It will be 23.6 plus 9.02, and the value of x8 will be what? The value of x8 will be 47.2 minus 9.02. So the value of x7 will be what? It will be 309.11, and the value of x8 comes out to be 319.35. To just uh, to represent the values, so it is 319.35 and this is 309.11, right? So moving ahead, so what we can write is f of x8 is greater than f of x7, right? Therefore eliminate, as it is a maximization problem, eliminate the region. Which region is to be eliminated? Left of x7. Therefore new interval that we are going to get, what is the value of x7? X7 is, sorry, this no, these values are of fx, and no, let me write the values of x7 properly. So it is 32.62 and x8 value is 38.2, right? And f of x7 is equal to 309.1, and no, f of x8 is equal to 319.35, right? So 319 point, so we are going to eliminate the region left of x7. So no, x7 is your 32.62 comma, we'll be getting it as 47.2. I guess we will be getting this as the last iteration to view, because the values are coming very near, right? So stage 5. Stage 5 new interval that we are getting is, new interval is what? New interval is 32.62 comma 47.2. I4, we can find out 47.2 minus 32.62 comes out to be 14.6. Let x9 and x10 be the points equidistant from the ends, right? So we can find out the I4 dash value, I4 star value. It will be I4 into, previously if it was n minus 3, so it will be n minus 4, and 2 digits back fn minus 6, so it is 14.6 into 89 upon 233, right? The value of I4 star comes out to be 5.58. The interval that we have is 32.62 and 47.2. Here we have x9 and here we have x10. So x9 and x10 is to be found out. X9 is equal to 32.62 minus 5.58, and x10 is equal to plus, and 47.2 minus 5.58, right? So x9 is equal to 38.2, and it comes out to be 41.62. F of x9 is equal to 319.35, and f of x10 comes out to be 319.47. So here we can say f of x9 is approximately equal to f of x10. So we can find out x star value. X star value will be what? It will be the average of I'll be writing it 38.2 plus 41.62 divided by 2. The value of x star comes out to be 39.91. Similarly, we can find out f of x star, and that value comes out to be 319.99. So this comes the final answer, right? So now, just one observation. If you did, I'll be just writing the x1 and x2 points, and accordingly the figure. So this finishes our numerical, but just to just give me a minute so that I can tell you how this is beneficial, how this is good. Here x1, I'll be writing only the points x1, x2, and here I will be writing f of x1 and f of x2, right? X3, x4, f of x3, sorry, x1, x2, f of x1 and f of x2, right? X3, x4, f of x3, f of x4. 5, 6, 7, x5, x6, x7, x8, x9, x10. Here f of x5, f of x6, f of x7, f of x8, f of x9, f of x10, right? Just give me 1 minute, and I wanted to make a point here. 38.2, 61.8, 319.35, 224.95, right? This was related with x1, x2, right? So x3 and x4, right? x3 we got it as 23.6, and x4 we got it as 38.2. f of x3 is 266.208. Here it is 319.35. x5 then we got it as 38.2, and it was 47.2. Here it is 319.35 and 309.63. Lastly, x7 we got it as 32.62, and it is 38.2. f of x7 is 309.11, sorry, 11, and f of x8 is 319.35. f of x9 is 38.2, and here it was 41.62. f of x9 here is 319.35, and here it is 319.47. So if you see, here the value, this x1 point 38.2, 38.2, 38.2, 38.2, 38.2. If you see, this is a common point that is getting repeated in every set of points. Similarly, the functional value of it is obviously going to remain same, right? Not going to change actually. So in every, how the computations are reducing, see, in every pair you got a 1 point, right, which is same and getting repeated, right? I don't say that only 38.2, ऐसा नहीं कि स्टार्टिंग का पेयर का कोई एक ही पॉइंट बहुत ज्यादा रिपीट होगा. ऐसा भी हो सकता है कि कोई 61.8 है या 23.6 है, that will get repeated in the another this thing. So at least 1 point is going to get repeated in every pair, and the functional value across that particular point you have already found it in the previous iteration or previous stage. So no need of finding out that particular value, you can directly copy. And plus this particular method will be when one point is continuously getting repeated, or either one of the point is getting repeated, So you also know that you are on the right track, right? Previously it was not so in dichotomous search method, right? When this is happening, no, at least one point of the previous stages is going to get repeat. So you get a confidence in the Fibonacci method that yeah, I'm going on the right track, and no, I'll be no, my answer at the last will be no, it will be right. So this is the beauty of the Fibonacci method. So you have iteration. Now you can see, you have 1, 2, 3, 4, 5. So five, particularly 5 times you didn't have to calculate that value. That calculate the value was just to be copied from the previous stage, right? So at least one point is going to get repeated from the previous stage in the next stage, and the value can be directly, it can be directly copied, and you will be getting a confidence that you are on the right track, right? So this was related with the Fibonacci method. So it is very easy method if you know understand only one formula to be remembered, and the Fibonacci series is not to be remembered, right? So it is, you can find that particular series, and just to some values you can particularly remember. For example, for F10, तो F10 का वैल्यू आपको रिमेंबर करना है, इट इज 55. तो जब आप लोग फिबोनाची सीरीज लिखते हो तो उस टाइम आपको एक क्रॉस चेक मिलता है कि मैंने जो वो याद किया था ना F10 का वैल्यू 55 है. वैसे ही आप F15 का वैल्यू फाइंड आउट याद कर सकते हैं, विच इज वेरी इजी टू रिमेंबर, 610, राइट. उसके बाद आपका F20 का वैल्यू भी याद हो जाता है 6765. तो जब आप लोग सीरीज लिखते हो तो आपको F10 का वैल्यू 55 मिलना ही चाहिए, F15 का वैल्यू 610 मिलना चाहिए, F20 का वैल्यू 6765 मिलना ही चाहिए. तो दैट पर्टिकुलर, अदरवाइज बस एडिशन करे और एक कुछ वैल्यू गलत हो गया तो आगे का सब वैल्यू गलत हो जाता है. तो ऐसे 3-4 वैल्यू कम से कम F10 का वैल्यू, F15 का वैल्यू और एक F20 का वैल्यू याद करके रखना है, कि जिससे एक क्रॉस चेक मिल जाता है एडिशन करते वक्त जब आप लोग सीरीज लिखने वाले. तो F10 का 55, F15 का 610 and F20 का 6765. These are the values you can remember, and then you can proceed.